This talk is on implementation, kind of the nuts and bolts of what it takes to get projects on the ground. So we're going to cover logistics, equipment, and safety. As a reminder, all of this information can also be found in Chapter 6 of the Design Manual. As a further reminder, this is phase 3 of the broader conservation planning process. And so here is where we actually implement the results of the planning and design that we've done in phases 1 and 2. It's important to note that even here, the process is still iterative. So some of the lessons you might learn, some of the things you learn about logistics in particular, can be used to evaluate, learn, adjust, or otherwise adapt to make implementation more efficient. So we're going to cover the logistics of implementation, some of the equipment needs you have, both the general and more specific, safety considerations, and we're going to spend a little bit of extra time on post pounding, the installation of posts, since it tends to be the area that most people are least familiar with when it comes to implementing these sorts of projects. Logistics. Logistics are a really important part of LTPBR projects because they require a lot of moving parts, a lot of different people involved, a lot of different areas you might be working in, different equipment needs, material needs, etc. And so managing these efficiently can be the difference between a smaller scale implementation and a much larger scale implementation. Related to that, some of the characteristics we generally associate with LTPBR are diverse workforces, including land managers, volunteers, nonprofits, consultants, the tendency to treat larger spatial extents, which by extension means construction of many structures and therefore a lot of material needs, and lastly, that these projects can be implemented in both remote or roadside settings, each of which carries with it its own specific series of considerations. So we're going to dive into each one of these separately. The workforce numbers you have and the different training needs you might have, material availability and transportation, site access, seasonal closures you might need to be aware of, and we'll give you some examples of those, and lastly, whether or not you choose to use posts. All of these are going to be really important in efficient implementation. First, workforce numbers and training needs. One of the great benefits of LTPBR projects is that they can engage and benefit from a pretty diverse workforce. That includes seasonal technicians, land managers, consultants, construction crews, volunteers. Just about everyone who can carry a bucket or a shovel can get involved in one way or another in these projects. Of course, what that means for those of us who are either planning or managing projects is that we need to be aware of the different levels of oversight or training all of these different individuals might have. You can imagine if you've mobilized a group of 20 different individuals coming from diverse backgrounds, that everyone's bringing different experiences to the table. And that has both really important implications for safety, most importantly, but also simply for the efficiency with which you can implement. Getting everybody on the same page with respect to the principles and the safety considerations is going to be really important. This is particularly important because any workplace injuries, should they happen, have the capacity to really shut you down, at worst shut you down, and at best just really slow down your implementation. The second very important thing to consider is your material availability. Is there an adequate source of woody material on site? Also, are there other local sources, for example, other upland restoration projects that can contribute woody material? Here what you see is a trailer full of juniper. And in the West, we do a heck of a lot of juniper removal projects. Oftentimes, if you're fortunate enough to be working in an area nearby one of these, you can use some of this material for the structures you're building. In areas where you don't have sufficient woody material, which is characteristic of a lot of degraded riverscapes, this can be both a sort of a win-win for both parties and really increase the efficiency of your implementation. Related to that, thinking about whether or not you can dive straight into the stream or whether or not you should be staging your materials. And so by staging, I simply mean collecting it and storing it somewhere prior to implementation. In projects where, for different reasons, you have seasonal closures, staging can be a really great way to start getting work done without actually getting into the creek. And staging can take place both in the sort of large roadside piles shown here, or at the scale of individual structures, because oftentimes a major time sink for restoration projects isn't just the building of structures, it's the getting the materials on site. And so thinking about the sort of ability to move materials earlier in the process can help speed things up later on. Site access is definitely a big component of that. And so here I'm showing just one example of a site in a remote setting. So to access this particular site, which is a little bit south of Boise, required about an hour and a quarter of driving paved roads, another hour on dirt roads, 1 hour on a 4x4 road, the kind of which you couldn't take a trailer on, and then 30 minutes on an ATV followed by a 30-minute hike, or for the more adventurous, perhaps an hour-long hike to get to the bottom of the site. That, of course, is going to be very, very different than a project that has roadside access the whole way, where you can more or less drive your truck, trailer, ATVs within 30 feet of the structures you're building, to the point where you might actually be able to even leave your post pounder in the back of the truck to pound posts. Both of these areas, both of these settings are absolutely appropriate for LTPBR, but they have very different planning, logistic, and safety implications to be aware of. They also have major differences in terms of what the overall cost of your project is going to be. Seasonal closures are also something to be aware of. You can't just get your stream bed alteration permit and jump right in the creek. In a lot of different places, for a lot of different reasons, you might have closures that prevent you from working either in-stream or even on the floodplain. And that's going to require consulting with federal and state agencies to understand what your specific project area, what closures your specific project area might have. A few examples. In the Price River in central southern Utah, there is a closure from June 1st through August 31st for the yellow-billed cuckoo, which is an ESA-listed species. So any work has to take place outside of that time window. In southeastern Washington, there's a in-stream work window that is just 2.5 months, from July 15th through September 30th, and that's for salmonids. So just check locally with whatever restrictions you might have. Another very common restriction, especially in the summer season, in drier climates, are fire restrictions. So checking the industrial fire precaution level, the IFPL, is going to be really important. Oftentimes in the hottest, driest times of year, you might have a 1 o'clock shutdown for things like chainsaws, post pounders. That's going to have really big implications for your installation of structures. It doesn't mean you can't be working during those times of year. It does mean that maybe you reorient your schedule to make sure you run the chainsaws and pound all of your posts early in the morning and then spend the afternoons weaving as to make sure you can get things in efficiently. So just things to be aware of. Lastly, to post or not to post. The decision to use post is something we've talked about in previous lectures during the design process, in particular, planning and design. But this is where we start to see what the implications of that decision are. When you buy posts, make sure they're untreated. Don't get the green ones. Posts can come in a range of diameters. They can be pre-sharpened or sharpened in the field, and they come in a range of prices depending on the particulars, depending on the nature of them, whether they're rough-hewn or smoother peeler cores. A note on pre-sharpening or sharpening in the field. It's tempting in a lot of cases to get the non-sharpened posts. Often they can be a little bit cheaper, but it's important to note that you might have to pay that cost back in the field. It takes a lot of time to sharpen a lot of posts, and running chainsaws is one of the more dangerous things we do. So whether or not the trade-off of a couple bucks a post is worth the time and risk associated with sharpening the field, something you should evaluate on a case-by-case basis. All of these different things, all these moving parts, are a great reason to use pilot projects. And so by pilot project, all I mean is a smaller scale project. In addition to being an opportunity to learn about the system's response, both geomorphically, hydrologically, pilot projects give an opportunity to address the uncertainties of complex logistics. In general, these projects are going to be smaller scale and therefore more expensive on a per structure basis. But in general, learning some of the ins and outs during a pilot project can make a full-scale implementation a lot more efficient and therefore save that money back that may have been spent during the pilot. One example from northwestern Utah in Grass Creek is that our pilot project consisted of only 20 structures across 3 different creeks. If you do the math, that's just under 7 structures per creek. But some of the things we learned in terms of site site access, material availability, the need for posts, the costs associated with moving different pieces of equipment, helped us scale up to 6 times that number the following year. Moving on to equipment. What are some of the equipment needs that we're going to have when we do these projects? The first and sort of most obvious are hand tools. When push comes to shove, building PALs and BDAs is manual labor, so we need the sort of standard suite of hand tools, including chainsaws, shovels, loppers, buckets, log carriers, shown here in the bottom right. We might also use grip hoists and the post pounder, and we'll spend a little extra time on the post pounder in a moment. You also might use ATVs or UTVs. These can be indispensable in making for a much quicker, more efficient implementation, both for transporting materials once on site and just moving over longer distances if you're trying to cover longer distances on a daily basis. For example, if you can't drive your truck down those last couple of miles, but you have an ATV, it saves you an hour's worth of walking. Post drivers. There are a range of different post drivers out there. At its simplest, you could use a sledgehammer. At its most complex, you can use a tractor-mounted hydraulic pounder. In between, you've got a couple different options. These are just simply things to be aware of, and there's more information in the manual on all of these. It's going to depend on both the resources you have available, whether this is equipment you already own or can borrow, and budget concerns. Partially, it's also going to depend on what the site demands. There are plenty of sites where a simple sledgehammer, manual post driver, or even a gas-powered post driver aren't going to be sufficient to install posts. We tend to use the hydraulic-powered, still manually operated, but hydraulic post pounder for most of our projects. It's quite heavy, and we'll talk more about that, but it tends to be the surest way to make sure that you can get your posts in. If you have access to heavy machinery, you can explore that as an option, but it's likely going to be more challenging to get that kind of machinery on site. If you want more information on some of the specific different models that are available out there, you can check out Appendix A in Chapter 6 of the Design Manual. When you buy a hydraulic post pounder, which is as shown here, there are still some things you can do aftermarket adjustments on to make it more efficient for using in the field, because this wasn't designed necessarily for toting around in the woods. And so larger wheels make a very big difference, for example. Also, building a small metal rack to house the actual post driver can really be helpful. A lot of the environments we're taking this material or this equipment into are not the sort of originally intended environment for this material. And so therefore, a few aftermarket adjustments can make your life a heck of a lot more comfortable, a lot safer, and a lot easier. Another piece of equipment that can be very, very useful in the field are boats or canoes. In areas where the floodplain is full of riparian vegetation, you might not be able to transport either materials, and most specifically the post pounder, through the woods, in which case having a boat to float it or a canoe can be very helpful. Wouldn't recommend getting anything nice here. Just get some old canoe that you don't mind dragging over rocks as you build. Make sure, of course, when you're doing this, that you don't build your structure and have your canoe on the wrong side of it so that you have to drag it over the structure afterwards. Safety. It's hard to sort of overstate. You can't really overstate the importance of safety. And so for the last number of lectures, we've talked a lot about the sort of conceptual underpinnings, some of the science behind LT-PBR projects and whatnot. But when it comes down to it, building these structures is construction work. It's not academic work, it's not landscape planning work, it is construction. And so all of the safety precautions that we would tend to associate with construction are in play here. None of them are being followed in these two particular photos, but it's very important to take this very seriously when you're out in the woods. And so we're going to walk through what those are and sort of how to mitigate some of them. There are a heck of a lot of construction hazards and associated common injuries. And so this slide is simply meant to indicate that on the left we have a whole bunch of hazards and what do they end up resulting in. So sharp tools. We're always carrying sharp tools, whether they be loppers, chainsaws, even really shovels and picks. This leads to, well, just about everything on this list. Sharp sticks. We're carrying the willow switches or large pieces of aspen that we've cut. So poked out eyes, cuts, bruises, splinters. We're always doing this work in slippery and uneven terrain, whether that, in the creek itself, on the floodplain, walking up and down banks. So now we're both carrying sharp tools and sticks over slippery terrain, so we're going to twist our ankles and then cut ourselves. We're using heavy tools. The post driver is very heavy. Dropping a post driver on your foot will break it, especially now that we're walking over uneven terrain with sharp sticks and heavy tools. We carry a lot of long posts and pieces of wood, which means that when we have a lot of people in one space carrying really long objects, we've again increased the hazards for poked eyes, heads getting knocked by posts, etc. We also use chainsaws, which means felled trees, which can lead to incredibly serious injuries. And finally, and arguably the most sort of influential on this list, is we're working with lots of enthusiastic people, which is a great thing, but also one of the most hazardous things that we have to deal with, because we have lots of enthusiastic people who are felling trees, carrying long posts and heavy tools over slippery terrain with sharp sticks and sharp tools. So all of these things can be mitigated, and that's really what some of the safety protocols we're going to cover are about. So broadly speaking, we can break safety up into a number of different categories, into communication, appropriate training, recognizing environmental hazards, recognizing construction hazards, and personal protective equipment. Starting with communication. Different organizations and agencies have different safety communication strategies, and often these are formalized in either job hazard analyses, tailgate safety sessions, morning safety briefings. There's a whole host of different ways we can do this. What's most important here is that you set aside some regular time to communicate all of the safety concerns that are part of working on these sorts of projects. That's going to include addressing the work site specific, activity specific, and environmental conditions on a regular basis. Some of the things we do also require more specific training. The training required to use a shovel is different than the training required to run a chainsaw. And so making sure that appropriate personnel have the training required for the task they're doing is critical. The most notable examples we have are chainsaw operation, driving, operating UTVs or ATVs, using grip hoists, and running the post pounder. I think it's safe to say that most people can be trusted to use a shovel, but unless someone has expertise in training running a chainsaw, they shouldn't be using a chainsaw. Like the Postal Service, we can do this work in all different conditions. And so acknowledging those conditions, those environmental hazards, is critical for the safe implementation of projects, because we can work in the rain, sun, heat, cold, snow, all of these different conditions, and all of those impact individual and group safety needs. And this should be commonplace to those folks who are used to working out of doors, but it's something that always needs to be explicitly acknowledged and mitigated for if necessary. We already covered a number of the common injuries and construction hazards, but as a reminder, we're always working on uneven, slippery ground that's full of tripping hazards. We're using sharp sticks and objects, heavy equipment, and as I like to refer to them, Larry, Curly, and Moe, in other words, your co-workers. And as much as you might adore your co-workers, you can't always trust them. So being aware of things like group spacing and pointing out unsafe behavior, having someone in charge to look out and keep their head up to look for that unsafe behavior is really important. Finally, personal protective equipment. When it comes to building low-tech PBR structures, this is the common suite of things we're going to need. We're going to need hard hats. That's going to help us, save us from getting whacked in the head by willows, posts, etc. We need glasses to keep us from getting our eyes poked out. We need ear protection because the post pounder or chainsaws are incredibly loud. And we're going to need gloves because, as silly as it is, nothing will ruin your day or make you a less efficient or impactful worker than a simple sliver on your hand. If you're running specialized equipment like a chainsaw or driving an ATV, there might be additional equipment you might need. For example, chaps if you're running a chainsaw, and helmets if you're, or ATV specific helmets if you're operating an ATV. Lastly, post pounding. The question is not how many people does it take to pound a post, but how many does it take to pound a post safely? And so some context to answer that question. The driver can be between 80 and 100 pounds. And by driver, I mean that piece of the post pounder that actually seats on top of a post. The hose itself is about 40 or 50 pounds. So imagine a very cumbersome, difficult to maneuver rope. And the generator, power pack, is about 200 pounds. How do we do it? Well, this photo illustrates. And you can see here, there are about 4 to 5 people that are actually involved in this process. There's one person manning the post, laying it down at an angle with their foot at the bottom of it, so the folks carrying that driver don't have to lift it above their heads. Because while a few of us might be able to carry the post pounder, and even fewer of us might be able to lift it above our heads, very few people, once it's above our heads, have any control over it. So having multiple hands on it is really important. And not lifting it above your head, if at all possible, is important. Once the post driver is seated on top of the post, it can be pushed up using all parties. You can see a lot of hands on that post, and then driven into the bed. It's important to note that the posts don't need to be vertical, something we've talked about previously. In this case, they happen to be vertical. Another important job here that sometimes is missed is someone simply holding on to the hose. Because once you've lifted that post driver above your shoulders, the last thing you need is for it to get caught on some root behind you, which limits your ability to finally move it where it needs to go, and now you're in a very compromised position. So the answer to the question, how many people does it take to pound a post, is about 4 or 5. That means someone who's moved the post into position, 2 to 3 people who have carried the post driver and got it on top of the post, and 1 person to manage the hose. In some situations, you might also have someone on the generator itself. That's both an important fire precaution and also just sort of convenient in terms of turning the generator on and off. In summary, effectively managing logistics can significantly increase your restoration footprint. It can be the difference between 50 structures or 100 structures. Because you can imagine for every moment that you have 15 or 5 to 15 people standing around is a lot of work that could be getting done. LT-PBR projects rely on hand tools and manual labor, and all of this requires appropriate safety training and equipment.